Okay, so now we need to evaluate this integral, right? So in the last class, that is the last video, so we need to evaluate double integral over r dou n by dou x minus dou m by dou y dy dx, right? Yes. So you can see the y varies from minus root 8x to plus root 8x, and x varies from 0 to 2, right? X varies from 0 to 2. So we need to integrate this to get the double integral over r dou m by dou x minus dou n by dou y dy dx. So we will integrate this now. So this will be integral 0 to 2, and you can see I need to integrate with respect to y. So that means 2x will be there. So integration of y is y square by 2. The limit is from minus root 8x to plus root 8x. So minus root 8x to plus root 8x, and plus 2x, and there is no y term here. So integral dy is nothing but y. So y of minus root 8x to plus root 8x dx, right? So we need to integrate this. Now we need to find the upper limit minus lower limit, and then we need to integrate with respect to x to find, and then we need to substitute 0 to 2. So I am just integrating double integral minus root 8x to root 8x 2xy plus 2xy dx. So when I integrate with respect to y, so we have 2xy square by 2 plus 2xy. So this will be integral 0 to 2. This 2 will get cancelled. So upper limit will be root 8x, right? Root of 8x. So root 8x square will be 8x minus this will be minus root 8x, right? So again upper limit minus lower limit. So this will be 0, and here this will be 2x. So upper limit is root 8x minus lower limit is minus root 8x. So it will be plus root 8x. So you can see this term will be 0. So we have integral 0 to 2 2x into 2 times root 8x dx. So this is nothing but 4x integral 0 to 2 root 8x dx, right? Root 8x dx. Now so this will be 4 times, so I can take root 8 outside. So it will be integral 0 to 2 x power 1 by 2 dx, right? So I can write root 8x as root 8 into root x. So x power 1 by 2 dx, this is nothing but 4x into root 8, and this is x power 3 by 2 to 3 by 2. The limit is from 0 to 2. So we have, okay, we have 4x, right? Yes. So this will be 4 times, I can take root 8 outside, and this will be integral 0 to 2 x into root x. You can see 1x is here, and here we have root x. So this is nothing but 4 times root 8 integral 0 to 2. This will be x power 3 by 2 dx, right? Because x power 1 into x power 1 by 2 is x power 1 plus 1 by 2, which is x power 3 by 2. So when I integrate this, we will have 4 times root 8 x power 5 by 2 by 5 by 2. The limit is from 0 to 2. So this will be 4 root 8 into 2 by 5. So 5 by 2 will be 2 by 5. Upper limit will be 2 power 5 by 2, right? 2 power 5 by 2. Now I need to simplify this. Now 4 2s are 8. So we have 8 by 5 into root 8 2 power 5 by 2. So I can take LCM now. So what is root 8 will be, so 2 4s are 2 2s are 2 root 2, right? So 8, this I can write this as 2 root 2 into 2 power 5 by 2. So I can write 2 as 2 power 1 by 2. Now I can multiply these two terms. So we have 16 by 5, right? 8 2s are 16. So 16 by 5, 2 power 1 by 2 and 2 power 5 by 2. This is nothing but 2 power 3, right? Because 2 power 6 by 2, 2 power 6 by 2 is 2 power 3. So 2 power 3 is 8. 8 into 16 is 128 by 5, right? So 128 by 5 is the value for surface integral, double integral over r dou n by dou x minus dou m by dou y, right? The value is 128 by 5. Now we need to find the line integral, right? So we have finished LHS. Now we need to find RHS. So you can see we are finding the double integral over R dou n by dou x into dou m by dou y dx dy is equal to integral over c m dx plus n dy. So we have finished this part and we have proved that the answer is 128 by 5. Now we need to do this part and then we need to prove that this answer is also 128 by 5. So again we have two paths. So y square is equal to 8x one path and x is equal to 2 is another path. So in order to find integral over c m dx plus n dy, so we need to consider two paths, integral c1 and c2. C1 is the path y square is equal to ax and c2 is the path x is equal to 2. Now for c1 we have y square is equal to 8x, y square is equal to 8x. So what is our c1? It is m dx plus n dy. So m dx, so it is already given there. The question is x square minus 2xy into dx plus x square y plus 3 dy. This is the integral, right? So for c1 we have y square is equal to 8x. Now what we will do is we will find x. Here what is x? X is y square by 8. Now we will find dx by dy, right? Because we have x is linear here. So dx by dy is nothing but differentiating with respect to y. So we have 2y by 8 is nothing but y by 4. So we have dx by dy is equal to y by 4. That means dx is equal to y by 4 dy, right? And you can see we are varying x, right? So y varies, again the path direction is this, right? So y varies from 4 to minus 4. Y varies from 4 to minus 4. So now this integral will be changed to where I can write. So I can write it here. So our dx is y dy by 4 and y varies from 4 to minus 4, right? Y varies from 4 to minus 4. Now we will erase this off. So this will be integral and you can see y varies from 4 to minus 4. So I need to replace everything in terms of y. So what is y here? X is y square by 8, right? So x square will be y power 4 by 64 minus 2x. So x is again y square by 8 into y plus x square. So x square is y power 4 by 64, right? Because x is y square by 8. So this will be y power 4 by 64 into y plus 3 into dy and again I have left dx. So dx is y dy by 4 plus x square. So x square is y power 4 by 64 y plus 3 into dy. So we need to integrate this entire term with respect to y and then we need to apply upper limit minus lower limit. So this will be integral 4 to minus 4. So here we have, you can see y is multiplied here. So I can take 1 by 4 outside, right? This 1 by 4 I have taken outside. So we have y. So y into y power 4 is y power 5 by 64. Y power 5 by 64. And again here we have 4 here. And this is y cube into y is y power 4. So we have y power 4 by 4 and again you can see here we have y power 4 into y. So this is plus y power 5 by 64 and here you can see nothing but 3 dy. So this substitute x to be equal to y square by 8. So there will be x y power 4 by 64 2xy. So x is y square by 8 into y, dx is y dy by 4 and here we have x square y. So x square will be y power 4 by 64, y is y again and plus 3 dy. So just integrate this. I think you can integrate this very easily. So if you integrate this, you will have answer to be equal to 24 right? So when I integrate and substitute upper limit minus lower limit, we will have answer to be equal to 24. So therefore this value is 24. Now we need to find C2, right? So let us say this C1. Now we need to find C2. So this is a very easy task, right? So just you have to apply y power n formula to integrate this. So for C2 you can see the path is from year to year, right? From path is from year to year. For C2 x is equal to 2, that means dx is equal to 0. Y varies from minus 4 to 4, right? Y varies from minus 4 to 4. You can see for C2 the path is from year to year. So x is equal to 2, and you can see x is 2 here, y varies from minus 4 to 4. That means dx is equal to 0. So what will be my integral over C2 m dx plus n dy. So this is nothing but integral over y varies from minus 4 to 4. And what is the question? The question is 3 yes, the question is x square minus 2xy dx plus x square y plus 3 dy. Now you can see x to be equal to 0, dx to be equal to 0. So that means this entire term will be vanished because dx is 0. So we have integral minus 4 to 4, x is equal to 2, right? X is equal to 2, so it will be 2 square. So 2 square is 4. So we have 4y plus 3 dy. So when I integrate this, we will have y in 4, I can take 4 outside, this is nothing but y square by 2 minus 4 to 4, and this is integral dy, this is minus 4 to 4. So this 2 will get cancelled, so we have 2, and the upper limit is 4 square minus 4 square plus 3 times, this will be 4 plus 4. Now you can see this entire term will be 0 because 16 minus 16 is 0. So this term we have 3 of 4 plus 4. So 4 plus 4 is 8. So we have this to be equal to 24, right? Because 4 plus 4 is 8. 8 into 3 is 24. This is 24. Sorry, actually the answer for this is not 24. It is 128 by 5 minus 24. Right, so I have written answer wrongly. For C1 you will get answer as 128 by 5 minus 24, right? And for C2 we have shown that this answer is 24. Now we will find integral over C. So kindly change this. The answer you will get will be 128 by 5 minus 24. So therefore this entire answer will be this plus 24 minus 24 will get cancelled. So we have 128 by 5. So therefore both are equal. So here also 128 by 5 and there also 128 by 5. Therefore Green's theorem is verified. So now I will move on to the next problem. So third problem is verify Green's theorem for integral over C 3x square minus 8y square dx plus 4y minus 6xy dy, where C is bounded by the region x is equal to 0, y is equal to 0 and x plus y equal to 1, right? This is the problem now. So verify Green's theorem. So that means we need to prove LHS and RHS and then we need to show that they are equal. So first we will find so for this m here, so m is m dx plus n dy. So m is 3x square minus 8y square and n is 4y minus 6xy. So what will be my dou m by dou y? So it is minus 16y and dou n by dou x is minus 6y, right? Yes. Now we need to find integral over r dou n by dou x minus dou m by dou y into dy dx. So that means integral over r. So dou n by dou x is minus 6y minus dou m by dou y is, this will be plus 16y. So this is nothing but dy dx. So this is nothing but 10y, right? I can take 10 outside. Double integral over r y into dy dx. Now we need to find the limits. So in order to find limit, we can see what is the diagram. We can see x is equal to 0, y is equal to 0, and x plus y is equal to 1. That means x is equal to 0. So x is 0 is this, y is equal to this is x is equal to 0, and this is y is equal to 0. And you can see from here I can conclude that y is equal to 1 minus x, right? Y is equal to 1 minus x. So a graph will be like this, right? So we need to find the point of intersection, this point and this point. So we have y is equal to 1 minus x, and you can see x is equal to 0, y is equal to 0. So you can see clearly the points are 0, 1 and 1, 0, right? Because this line is y is equal to 0, and you can see when y is equal to 0, x is 1. When y is equal to 0, x is 1. So we have 1, 0 as this point, and here you can see our y is 0. Sorry, x is 0. So when x is 0, y is 1. So therefore the points are 1, 0 and 0, 1, right? So we need to go like in this direction. And this point is 0, 0. Now for finding x limit, you can see our x varies from 0 to 1, and for y you can see this is a bound for y, right? So you can see y varies from 0 to 1 minus x, right? 0 to any point 1 minus x. So therefore the integral will be 10 times integral 0 to 1 integral 0 to 1 minus x y dy dx. So this will be 10 times integral 0 to 1. So integral y dy. So integral y dy is y square by 2. The limit is from 0 to 1 minus x dx. So I can cancel this 2 and 10. So we have 5. So we have 5 times integral 0 to 1 minus x whole square dx. So we need to integrate this. So we have 5 times. So when I integrate this, we will have 1 minus x whole power 3 by 3, and here we have minus 1, right? Because derivative of x is 1. So limit is from 0 to 1. So we have minus 5 by 3 outside. Minus 5 by 3 outside. So upper limit will be 1 minus 1 whole cube minus lower limit will be 1 minus 0 whole cube. So this will be 0, and here we have minus 1. So minus 1 into minus 5 by 3 is plus 5 by 3. So therefore the double integral over r dou m by dou x minus dou m by dou y dy dx is 5 by 3. Now we need to find the line integral, right? We need to find line integral. Now what we will do is we have 3, right? We have 3 regions C1, C2, C3. Let us say this C1, this is C2, this is C3. Now for C1 you can see x is 0. For C1 you can see x is 0 and y varies from 0 to 1. And for C2 you can see y is 0, x varies from 0 to 1. And for C3 we need to evaluate, right? So let us say this is O, let us say this is A, let us say this is B. So we have finished the first part. So now we need to find the LHS, right? Yes. The answer is 5 by 3. So first we will find OA, right? So we need to find integral over m dx plus n dy. So we need to show that this value is also equal to 5 by 3. This value also equal to 5 by 3. So for that what I am going to do is I am going to split this into OA and then AB, right? OA and then AB and then BO. So this is B. This is B, OA, AB and BO. So first we will find OA. So for OA you can see y is equal to 0, right? For OA we have y is equal to 0, that means dy is equal to 0, and you can see x varies from 0 to 1. X varies from 0 to 1, right? Y is equal to 0, or else you can also use the equation y is equal to 0, and x varies from 0 to 1. So we have integral C. So our m is 3x square minus 8y square dx plus 4y minus 6xy dy is equal to, this is the region OA, and for OA you can see dy is 0, this entire term will be vanished, and y is 0, this will be 0. So we have integral 3x square dx, and x varies from 0 to 1, this is nothing but 3 times x cube by 3, 0 to 1, so this is nothing but 1. Therefore the value for this is 1. Now we need to find AB, right? We need to find AB. So for AB we have, you can see for AB, let us do one by one. Now AB. Now for AB you can see y, you can take either y is equal to 1 minus x or x is equal to 1 minus y, that is your wish, right? You can take any two. So I am just taking x to be equal to 1 minus y. So that means dx is equal to minus dy. So I am taking everything in terms of y. So you can see our y varies from 0 to 1, right? For AB y varies from 0 to 1. You can also take y to be equal to 1 minus x, and dy will be minus dx, and x varies from 1 to 0. You can take any method. So from this now this will become integral AB 3x square minus 8y square dx plus 4y minus 6xy dy. This is equal to, you can say dx is same as minus dy, and x is equal to 1 minus y. So this will be y varies from 0 to 1. So y varies from 0 to 1, and 3x square. So 3 into 1 minus y whole square minus 8y square dx. So dx is minus dy plus 4y minus, so x is 6y into dy. Now you need to evaluate this integral, right? So I think you can easily evaluate. You just have to integrate every term with respect to y, and then you need to apply 0 to 1. So if you do that, you will have the answer to be equal to 8 by 3, right? These are just a normal integration using x power n formula, right? Okay. Now we have found this, so this is equal to 8 by 3. Now we need to find BO, integral BO, right? So this will be 8 by 3. Please do this. So it's nothing but just integrate separately. So you can take minus outside. So we have 3 times 1 minus y square dy minus 8y square dy, 4y dy plus 6y minus 6y into 1 minus y dy. So integrate separately, you will get the answer as 8 by 3. Now for BO, you can see x is equal to 0, right? For BO, x is equal to 0, that means dx is equal to 0, y varies from 1 to 0, y varies from 1 to 0. So therefore integral BO will be 3x square minus 8y square dx plus 4y minus 6xy dy. So dx is 0, this term will be 0, and again x is 0, this term will be 0. So we have integral 4y dy. So this is nothing but, and you can see 1 to 0, right? Y varies from 1 to 0. So I can take 4 outside, and this will be y square by 2, 1 to 0, and upper limit minus lower limit we have minus 1 by 2, so which is minus 2. So this answer is minus 2. So we need to add up all this to get the entire line integral. So therefore integral over C 3x square minus 8y square dx plus 4y minus 6xy dy is equal to, you need to add up OA, AB and BO. So we have 1 plus 8 by 3 minus 2. So we have 1 plus, this is 8 minus 6, which is 2 by 3, and this is 5 by 3. So we have shown that we already found that double integral over R dou n by dou x minus dou m by dou y dy dx, right? That is also equal to 5 by 3. Again, this is also equal to 5 by 3. So therefore, Green's theorem is verified. So I will move on to the next problem. Evaluate by Green's theorem. So if the question contains verify, you need to find both LHS and RHS, and you have to show that both are equal. Suppose if the question is like this, so the fourth problem actually is very easy. You just have to find the line integral, and then you have to find double integral over R dou n by dou x minus dou m by dou y dy dx, and you have to show that both are equal. Now the fourth problem is evaluate integral over C x square minus cos hy dx, x square minus cos hy dx plus y plus sin x dy, y plus sin x dy. You can see we need to evaluate by Green's theorem. Evaluate by Green's theorem, where C is the rectangle, where C is the rectangle with vertices 0, 0, pi, 0, pi, 1 and 0, 1. Now we can easily do this by line integral, right? So how you will do by line integral? Now we need to evaluate by Green's theorem. Suppose if they didn't say to find by Green's theorem, we can use line integral very easily. So what is a rectangle here? So this is 0, 0, pi, 0. So let us say this is our pi, 0. This is pi, 1. Let us say this is our pi, 1. This is our pi, 1. This is pi, 1, and this is 0, 1. So this is our rectangle. This is our rectangle now. So this is the region. So first when you are coming like this, you are going like this, you are going like this, you are going like this. We can easily evaluate by line integral, right? So let us say this is our O, A, B, C. So by line integral, what you will do? You split this into 4 parts: integral OA, integral AB, integral BC, integral CO. And for OA, you will take y to be equal to 0. X varies from 0 to pi. Since y is equal to 0, dy is equal to 0. So and for AB, y is equal to pi. Y is equal to pi. That means dy is equal to 0 again, and x varies from 0 to 1. And for BC, y is equal to 1, right? Y is equal to 1. This is nothing but y is equal to 1. This is nothing but x is equal to pi. This is y is equal to 0. This is x is equal to 1. And for CO, you will take x to be equal to 1. That means dx is equal to 0. Y varies from 1 to 0. You can easily do this by line integral, but we need to evaluate this by Green's theorem, right? Yes. So how we will do this by Green's theorem? So what Green's theorem says? Integral over C m dx plus n dy is equal to double integral over R dou n by dou x minus dou m by dou y dy dx. So in order to find this, we need to find this, right? This is what they have said. So they have said to evaluate by Green's theorem. So therefore, we need to evaluate double integral over R. So this is m dx plus n dy. So what is dou n by dou x? So it is minus cos x dy, sorry, minus cos x, right? Though n is y plus sin x, so y plus sin x is and minus, sorry, sin x is cos x, right? So cos x minus dou my dou y. So cos hy is sin hy. So we have minus minus here. This will be plus sin hy dy dx. And you can see y has to be some function, right? Y has to be some function limits, and x has to be. Now you can see overall you can see y varies from 0 to 1, right? So y varies from 0 to 1, x varies from 0 to pi. So this is nothing but integral x varies from 0 to 1, x varies from 0 to pi, right? X varies from 0 to pi. Overall y varies from 0 to 1 cos x sin hy dy dx. So when you are doing this an integral, we will have 4 parts that will take time, but if you do this you will have only a single integral, so we will finish this very easily, right? Yes. So what you have to do is you evaluate this by line integral. We will have 4 parts, right? OA, AB, BC, CO, and you do this by line integral, you will get the same answer. Now we need to integrate this with respect to y and then with respect to x, right? Okay, we will integrate this. So this is nothing but 0 to pi. So integral dy cos x is y cos x, right? Integral dy is y, cos x is constant, and integral sin hy is nothing but cos hy 0 to 1, limit is from 0 to 1 into dx. So this will be integral 0 to pi. So when you integrate this with respect, so okay, we will substitute upper limit and lower limit. So we have y into cos 1 plus cos y into cos 1, okay, cos x, right? We are only substituting for y. So we are only substituting for y. So the entire upper limit will be 1 cos x plus cos h1 minus lower limit. So 0 into cos x plus cos h0 into dx. So we are only substituting for y. So upper limit is y, cos x will be there, and lower limit will be 0, 0. And you can see the cos h0 is 1, so we have this to be equal to, integral 0 to pi cos x plus cos h1 minus 1 dx. This is the one you have. Now we integrate with respect to x. So integral cos x is sin x. So sin x limit is from 0 to pi plus cos h1 is constant. Integral dx is x 0 to pi, and again this is x 0 to pi. Now we find upper limit minus lower limit. So you will have this to be equal to sin pi minus sin 0. This entire term will be 0, and here you have cos h. Okay, well we need to substitute only for x. So this will be cos h1 into pi, right, minus pi. So if I take pi outside, getting pi. Okay, if I take pi outside, we will have cos h1 minus 1. This is the required answer, right? Yes. So I will move on to the next problem. I'll do this. Actually, if you understand this problem, we can do this problem easily. So, fifth problem is this is very time saving, right? So, whenever you integrate a line integral, actually line integral is very easy, but it will take time. But if you transform that to Green's theorem, then you will finish this very easily. So, fifth problem is evaluate. So, whenever you are done with evaluate by Green's theorem, you have to use the formula dou n by dou x. So, evaluate by Green's theorem. Evaluate by Green's theorem. Integral over c e power minus x sin y dx plus e power minus x cos y dy, where c is the rectangle, where c is the rectangle with vertices. Same problem, different question with vertices 0 comma 0, pi comma 0, pi comma pi by 2 and 0 comma pi by 2, right? Again you can see what Green's theorem says. Integral over c m dx plus n dy is same as double integral over r dou n by dou x minus dou m by dou y dy dx. In order to find this, it is enough to find double integral over r dou n by dou x minus dou m by dou y. So, this is double integral over r dou n by dou x. So, this is our m dx and this is n dy. So, if you differentiate with respect to x, so we have minus e power minus x cos y. Cos y is constant, e power minus derivative is minus e power minus x minus dou m by dou y. So, again e power minus x will remain as it is. So, sin y is cos y into dy dx, right, minus e power minus x. Yes, again you can see both are same terms, e power minus x cos y, e power minus x cos y. This is nothing but minus 2 e power minus x cos y dy dx, or else I can also take minus 2 outside. So, this is the integration. I have taken minus 2 outside. Now, we need to find the limits, x limit and the y limit. So, you can see our rectangle 0 comma 0 is 1 point and pi comma 0, let us say this is our pi comma 0 and pi comma pi by 2, let us say this is our 0 comma pi by 2. So, this is pi comma 0, this is 0 comma 0, this is 0 comma pi by 2 and this is pi comma pi by 2. Again you can do this by line integral also. If you are doing a line integral, we have this is nothing but x is equal to 0 and this is y is equal to this is y is equal to 0 and this is x is equal to pi and this is again y is equal to pi by 2 and this is x is equal to 0. So, again you can use this line integral also to find let us say this is O, let us say this is A, this is B, this is C. Now, we split this into 4 integral OA, integral AB, integral BC plus integral CO, and for every integral you can easily find by line integral, but I am going to use Green's theorem now. You can see overall x varies from 0 to pi, right, x varies from 0 to pi and overall x varies from 0 to pi and y overall varies from 0 to pi by 2. So, it is 0 to pi by 2 e power minus x cos y dy dx. So, I think you can integrate this very easily. So, this will be I need to integrate with respect to y. So, we have minus 2 outside, this is 0 to pi and here I can take e power minus x outside and integration of cos y is sin y, limit is from 0 to pi by 2 dx and sin pi by 2 is 1, sin 0 is 0. So, we have upper limit to be equal to 1. So, this limit is from, so this will be minus 2 integral 0 to pi. Overall we have e power minus x sin pi by 2 minus e power minus x sin 0. So, we have this to be equal to e power minus x sin pi by 2 is 1. So, if we integrate this, we will have e power minus x by minus 1. So, this is nothing but 2 0 to pi e power minus pi minus e power 0. So 2 times e power minus pi minus 1. So 2 times e power minus pi minus 1 is the required answer, right? 2 times e power minus pi minus 1. We can see when you use Green's theorem, the problem will be very easy for you. Now I will give you one problem for exercise. So what that problem is, so 6th problem is exercise for you. So what that problem says is, so same question. So Green's theorem tells a relation between the line integral and surface integral. So whenever we are using double integral, you think that of as a surface integral. So 6th is, if f is equal to x square minus y square I vector plus 2xy j vector and r is equal to xi plus yj, find the value of integral f dot dr around rectangular region bounded by x is equal to 0, x is equal to a, y is equal to 0, y is equal to b. Now again you can easily prove this by line integral. You already solved this sort of problem in line integral, but now I am going to use surface integral, Green's theorem. So this will be integral f dr will be integral f dr. So dr is dx I vector plus dy j vector. F is this. So we have x square minus y square dx plus 2xy dy. This is our f dot dr. So dr, from here you can see dr is, we already know, right, dx I vector plus dy j vector. So when you make a dot product with f dot dr, I will get cancelled, I will be 1. So x square minus y square dx plus 2xy into dy. So we need to evaluate, we are going to evaluate this by Green's theorem. So in order to find this, I can find double integral over r dou n by dou x minus dou m by dou y dy dx. You can see our rectangle is 0, right, 0 comma 0, and this is a comma 0, and this is a comma b, and this is 0 comma b. Now you can see overall our x varies from 0 to a, and overall y varies from 0 to b. Y varies from 0 to b. What is dou n by dou x? This is m dx plus n dy. So dou n by dou x is 2y minus dou m by dou y. So m with respect to y, so minus 2y we will have. So minus 2y minus 5 will be plus 2y dy dx. So this is 4y, so I can take 4 outside. Integral 0 to a, integral 0 to b, y dy dx. So this will be 4 times integral 0 to a. So y dy is y square by 2. So y square by 2, when I substitute upper limit minus lower limit, we will have b square by 2 dx. Now I can take 4b square by 2 outside. Integral dx is x, the upper limit minus lower limit will be a. So we have 4a, I can cancel these two also. So we have 2ab square is the answer. 2ab square, right? So if you use Green's theorem, you can see how easy it is, right? So if you are finding by line integral, what you will do? You will write, this is nothing but y is equal to 0, this is y is equal to b, this is x is equal to 0, this is x is equal to a, and you can see you will take let us say this is our C1, this is C2, this is C3, this is C4. So you will evaluate 4 integrals, integral C1, integral C2, integral C3, integral C4 will take time, but by using Green's theorem you can see We have completed this problem in less than 2 minutes. Okay, the last problem, apply Green's theorem to evaluate seventh problem, apply Green's theorem to evaluate integral over C y minus sin x dx plus cos x dy, where C is triangle enclosed by the line, y is equal to 0, x is equal to 2 pi, and pi y is equal to 2x. Now this is a triangle, right? So therefore we have y is 0, this is our y, sorry. So this is y is 0, x is 2 pi. So from this we can conclude that y is equal to 2x by pi, right? So our function is y is equal to 2x plus pi, so that will be a line, and x is 2 pi. So when x is 2 pi, y will be, when x is 2 pi, let us say this is our 2 pi, when x is 2 pi, our y will be 2x by pi. So 2 into 2 pi by pi, y will be 4. This is 2 pi zero comma 0. So it is given that y is 0 and y is this, and x is 2 pi or pi by 2. Okay, this is pi by 2, it is not 2 pi, this is pi by 2. Yes, this is pi by 2, it is not 2 pi, it is pi by 2, right? So let us say this is our pi by 2. So when x is equal to pi by 2, what will be my y? Y is 2 by pi into x. This will be 1, right? This will be pi by 2 comma 1, and this line is nothing but x is equal to pi by 2. This is y is equal to 0, and this is y is equal to the line y is equal to 2x by pi. Y is equal to 2x by pi. Right, that's it. Now we can also integrate by line integral also. So we can go by this way. For this way, this is a point 0 comma 0. This is pi by 2 comma 0. This is pi by 2 comma 1. And you can see here y is equal to 0, dy is equal to 0, x varies from 0 to pi by 2. And for this path, x is equal to pi by 2, dx is equal to 0, y varies from 0 to 1. And for this path, you have to take y is equal to 2x by pi. You can easily evaluate by line integral, but now we are going to do that by Green's theorem. So in order to evaluate this integral, what we need to find? Double integral over r dou n by dou x minus dou m by dou y dy dx. So what is this? Is our m dx, this is n dy. So dou n by dou x, so cos x is minus sin x, so double integral over r minus sin x minus dou m by dou y, so this is nothing but 1 into dy dx. Okay, now we need to find y limit and the x limit. Now you can see y varies from 0 to 2x by pi, because it is a function, right? So y varies from 0 to 2x by pi. So this will be, and x varies from 0 to pi by 2. So x varies from 0 to pi by 2, y varies from 0 to 2x by pi, and this is minus sin x minus 1 dy dx. So I think you can easily integrate this, right? So integrate with respect to y, integrate with respect to y. So this will be minus sin x y minus y, and then you integrate with the and then you find upper limit is lower limit, and then you substitute integrate with respect to dx. So you will have at the last you will have the answer to be equal to minus pi by 4 minus pi by 4 minus 2 by pi. This is the answer, right? So I think this is a very easy task. You just have to integrate, and then you need to substitute upper limit and the lower limit. Okay, so that's it. So we have solved some problems. So tomorrow also we will be solving some more problems from Green's theorem, and then we will move on to surface integral, right? So far we have seen line integral, and with the help of Green's theorem we are evaluating line integral. In order to evaluate integral c m dx plus n dy, by Green's theorem we are evaluating double integral over r dou n by dou x minus dou m by dou y dy dx, right? So that's it. So we will continue tomorrow. Thank you.